In this video, our goal is to solve a system of equations using inverses. Before we get into that, I would like you to go back and look at Cramer's rule and practice that here. Solve this system of equations using Cramer's rule. So pause it for a moment, go through that process, make sure you can still do that. So when all is said and done, after you go through using Cramer's rule, you end up getting x to be 2, y to be -2, so you get that coordinate point. Okay. Cramer's rule, 2 by 2, usually very straightforward. 3 by 3s take a little bit more time. For inverses today, we can strictly use 2 by 2s. Okay. For inverses, we strictly are going to be working with 2 by 2s by hand. If we do 3 by 3s, we have to go to our calculator. So recall that to find an inverse, it's just 1 over the determinant of A times the flipped around matrix. We're going to be using this process to solve our system of equations. So just like we did for Cramer's rule, I have to pull out my A matrix and my B matrix. So this is the part of why do we actually use inverses? How does this help us? So to begin with, I'm going to write down my A matrix. So my A matrix is the coefficients, 2, -3, -1, 4. Make sure they're lined up. And B matrix, as before, is my answer matrix, 10, -10. Now what I'm actually going to do is I'm going to show you what this actually represents, because not only do I have an A matrix and a B matrix, I also have what's called an unknown matrix, my X matrix. It is all capital letters, because what really happens is I take that A matrix and I multiply it by this unknown X matrix, and my result after I do that is B. That unknown X matrix is those unknowns. It's 2, -3, -1, 4. My X matrix, that unknown matrix, is my X and Y values. And then it equals my B matrix, which is my unknown matrix. Now let's look at this. Let's go through multiplication. You guys have done multiplying matrices, rows by columns. I take this row, I multiply it by this column. So 2 times X plus a -3 times Y, top, equals 10. That's the first row there, or the first statement. And then this row by this column, -1 times X plus 4 times Y equals -10. So that's why it works. That's how we can actually pull them apart. Logistically, mathematically, everything supports itself. That's why we go through everything before we actually get to this case. So when I go through and I do the actual multiplication, I get back up to that initial problem. This is a system of equations. This is my matrix form. Two different ways of looking at things. You can go backwards and forwards between the two. If you like one and don't like the other, you can flip-flop between them. But what our goal is we have to figure out what X and Y are. I have this statement. I need to find that, which is here. So I need to isolate X and Y. So that X value. So I have to get rid of A. I don't want A. I can't have A. Well, A is attached to X by multiplication. Unfortunately, there's no division of matrices. Since there's no division of matrices, I have to undo the multiplication operation. What undoes multiplication? The inverse of multiplication, A inverse. Now, if you remember, back when I was going through inverses, I took the inverse of A, multiplied it by A, and I got the identity. Well, it's the same thing as if I'm multiplying by 5, I divide by 5 on both sides, and I get 1. Goes away, but it really doesn't go away. It's 1. It's the multiplicative identity. Or if I have to subtract 3 on both sides, I get 0, the additive identity. So here, I have to get my matrix identity, 1, 0, 0, 1. So that's kind of the point of where we're going with all of this. I need A out of the picture. So I have this A matrix, and then I have my X matrix, and that equals B. So I have to get rid of A because I got to get X by itself. In order to get rid of A, I multiply by the inverse of A. What I do to the left side, I also have to do the right side. Keep in mind, order matters when we do multiplication. Well, the inverse of A times A, as I showed you in the inverse video, is 1, 0, 0, 1. And that's multiplied by this X matrix. And that equals the inverse of A times B. When you're doing division and you get 1 times X, do you leave 1 there? No, it's just X. Same thing here. The identity matrix times x is just x. So to find that x and y, I have to take the inverse of a and multiply it by b. That's really what the goal is. What I just showed you here is the process as to why it works. This is the statement that's the most important. I have to take the inverse of a and multiply it by b. That's going to give me my x matrix, my unknown matrix. Remember, x matrix is the unknown matrix, my x and y values here. So this is my goal to figure out. So in order to do that, I have to calculate the inverse of a and then just multiply by b and I have my answer. You don't have to go through all of this work down here. You just have to find the inverse of a and multiply it by b, which is 10, negative 10. So let's do that. So the only work I have to do is A, calculate the inverse of A. Okay, first, calculate the inverse of A, then multiply it by B. And that's going to give me my x value, which is my coordinate point. So I have to go through some work calculating the inverse of A. So the inverse of A is 1 over the determinant of A times that flipped around matrix. 4 and 2 change spots. 3 and 1 stay in the same spot but change negations. I have to find the determinant of A. I'm going to do that down here for a second. Determinant of A is 2 times 4 minus negative 3 times negative 1. So 8 minus 3, which gives me 5. So 5 is the determinant of A. So this is 1/5 times 4, 3, 1, 2. Therefore, the inverse of A is 4/5, 3/5, 1/5, 2/5. That's the inverse of A. And now, so that's this part here, I have to multiply it by B, which is 10 and negative 10. And once I do that multiplication, you guys have done multiplying matrices, I get my answer. So now I just have to remember row by column. This entire row by this entire column. 40/5 plus negative 30/5. And this row by this column is 10/5. Oops, this is all one matrix. 10/5 plus negative 20/5. And now just simplify, which gives me 8 plus a negative 6 and 2 plus a negative 4, which gives me 2, negative 2. Now, this is my unknown x matrix. My unknown x matrix, as I had stated earlier, is in this case x and y, because that's how the problem is stated. Top is x, bottom is y. System of equations is a point that these two lines intersect, which is 2, negative 2. All that work to calculate the inverse. However, it should be exactly the same as what you found when you did Cramer's rule. Different type of work that you have to do. So here are the two different situations that we had to do. The one on the left you solved using inverses. The one on the right you did Cramer's rule with. Depends on what you feel most comfortable doing. You do get fractions along the way, but you have to understand the process as to why we use inverses. The biggest thing for why we use inverses is to get x by itself. Because this is what the process that you're going to be working through to figure out other different pieces of information. What I would like you to do is use inverses to solve this problem for x and y. I will have all the work up that you'll be able to look through, but see what kind of questions you have along the way, if there's different pieces of information that you're struggling with. So pause it for just a moment, go through the process. And here's the solution. Found the determinant of A, calculated the inverse, 1 over the determinant of A times that flipped around matrix, found the inverse matrix. took the inverse matrix, multiplied it by b, and I ended up with the coordinate point 4, 1. So you have a couple of practice problems to do this with, figuring out how do you do inverses by hand, as this will be part of the requirement.